I'm Daniele Frasca. My name is Daniele Frasca, working at ProSiebenSat.1 Media, Germany. I'm Italian, from the accent. Today we are going to talk how we integrate Kafka with a serverless applications. We will move to a couple of integrations and see some limitations. In the end, we'll see a fully event-driven applications without any type of code, and we will finish with my AWS wishes. ProSiebenSat.1 Media is a German TV broadcaster, operating 3 different segments: dating, e-commerce, and entertainment. I'm part of the entertainment group. We heavily invest in AWS. This is our daily usage, and I contribute on the server side of the things. With me, there is Roman.
Yeah. Hi, everyone. My name is Roman, and I work as a specialist solutions architect for serverless at AWS. And usually what I do, I work with customers like ProSieben and Daniele, and they come to me with tons of questions, how to build things, how to implement things. And yeah, we work as a team together to help them build all that things. And yeah, today we are going to base our talk on our journey, how we built this particular solution, how we interact with each other, and how we came up to the solution in the end.
This talk actually reflected the way I work with AWS, and especially with Roman. I usually get a challenge in the form of a team or a project. I do my analysis, I come up with a plan, and then I double check with Roman if my AWS design is missing some elements. As a team leader of content discovery team, I own few services. And we currently have 2 products. Those products are present in multiple regions: Germany, Austria, and Switzerland. We call the DACH region. What they have in common is just the naming. And the 2 products, they are built with 2 separate backend. They have different technology, different framework. My goal is to unify them and give one seamless experience to our end user, regardless from the countries and the platform. What they have in common is the architecture at a high level. We have a company bus and a cluster per service, and the naming of the service. Everything is duplicated. So I decided to move to serverless because when I was looking into the implementation of all these clusters, I noticed a few problems. The deployment times was very long. Each of them implemented their own type of subscription to the topic of Kafka. Sometimes they handle error in a different way. They throw, they swallow the error, but mostly all of those clusters could not handle sudden spike traffic. So because the complexity of merging 2 different backends is quite high, I want to remove from my plates a few problems, like availability and scalability. So because of this, I moved to the AWS serverless offering that is pretty much 2 things. They are taking care of availability and scalability, and we developers just focus on what really counts: implementing code and delivering values. So this was my first question to Roman. Why Kafka? How can I implement it with serverless?
Yeah, and actually, when we started looking at this solution, it looked to me that, it looked simple, like one cluster consuming events from Kafka, and maybe another cluster consuming also events from Kafka. But it turned out quite soon that, this Kafka was using like a central EventBridge. So, and I was asking Daniele questions, how you are using this Kafka. So you're using as a service bus. This was the main case, but it was also used for some other things as well. So it was used for asynchronous communication between different services. Probably some of them were using it as a database, which is not the good case, and it was more look like a mess, because now everyone was putting events to the Kafka event buses. and it was more like not as specific domain events, but also quite wide events, and then different consumers from different departments were also connecting to this central Kafka bus. And we started thinking that, yeah, probably there might be another option how you can decouple events within a particular domain Daniele was responsible for, and we start discussing different options. And one of the idea was if you still have this Kafka as a central bus and you can't get rid of it anyway because it's like a company standard and you still have to do something. But if you want to decouple and you want to have like a better management of your own events within your own domain, probably there's another option how you can do that. And we started looking at EventBridge bus as a central event bus for a specific domain where Daniele was building things. And yeah, event bus, if you don't know, it's like a serverless AWS service which allows you to get events from different producers. Then you can define different rules which allow you to route those events to different consumers. And the next question we started to discuss between myself and Daniele was whether it is event router or whether it is an event store. And it turned out that if you use Kafka, you usually use it more like an event store. And yeah, it is more like a buffer between different microservices or different components within your system. But another implication of Kafka is that now at the current architecture, each consumer have to pull events out of the Kafka topic, and there were different implementations, maybe with different solutions, and some of the developers decided to swallow errors, some of them decided to process some errors, but there were no consistency of how they consume events from Kafka. And one of the ideas at first we were talking about is that, yeah, we can standardize if we move out from using ECS and cluster with containers to Lambda functions, because, yeah, Lambda can implement this consuming events from Kafka. There's an event source mapper and built-in functionality within Lambda, and you can standardize how you can consume events. But then we realized that, yeah, there's another problem with Kafka is that, yeah, it's tightly coupled with all the domains, and we came to this event router mechanism when we want to have like a dedicated system which allows us to define different rules, how we want to distribute those events, and yeah, of course, decouple producers from consumers. But now one of the differences also we observed is that EventBridge now pushes events to the different consumers, to Lambda functions or to API destinations, for example. And now it's more like a responsibility of the EventBridge to make sure that the event is delivered to the final destination. And now on the consumer side, you have like easier implementation, so you don't need to work with many things and errors. And it has additional capabilities like retries and filtering. But then came the question, yeah, we have this Kafka central bus, and now we want to implement new functionality with EventBridge, and but still we need somehow connect them, because still we have this central bus and we can't get rid of it, so we need connect. And Daniele asked, how can we do that? And my first suggestion to him was, there's another part of EventBridge which is called EventBridge pipes, and probably it can solve your question, and it can help you to build this bridge between Kafka and EventBridge, and you started to experiment with that.
Yes, so EventBridge Pipe is an amazing service. It takes care, it's taking care of the point-to-point connections for us, And when you associate with EventBridge as a target, it becomes very powerful because now you can listen to any type of changes and fan out to your downstream services. Pipes are coming with so many features, events, filter events, batch events. Higher is the batch, higher is the throughput. But it's keep the order of the events that are coming from Kafka. But what is very interesting for me was the enrichment pattern. With the enrichment, I can intercept the source message, modify in a way that my downstream services can understand it. All of these features together allow me to standardize the way we interact with Kafka topics. And because a lot of features are already built in, I don't write a code. I don't need to write an implementation for whatever source we are using or whatever target. It's all taken care from the EventBridge pipe. And this actually allows me to reduce the time to market for our applications. Even though if I want sold with EventBridge pipe, I always ask the next questions. Do we have alternative?
And it was an interesting question because, yeah, usually if you work with AWS, you know that there are different ways to solve the same problem. There are similar services and similar ways of doing that. And when Daniele asked me this question, really, I realized that, yeah, there's another alternative how you can connect Kafka with EventBridge. And it was a standard way. So if you used Kafka, you know that there's a certain specification which is called Kafka Connect. And it allows you to either consume events from different sources and push them to Kafka, or it can also you can also build a connector because it's like an interface, and you can implement this interface to get to Kafka topic and to produce those events to the EventBridge. And then one of our colleagues inside of AWS, they built this open source Kafka connector. And essentially, it allows you to connect to different Kafka implementations. So it doesn't matter whether you have Kafka running on-prem or you have Kafka managed by Confluent or Kafka managed by MSK. It's the same implementation. And the good thing here is that for some customers who want to connect, for example, Kafka running on premises, there's no way to connect EventBridge pipes to Kafka on-prem because might be different network security policies which don't allow you to expose a Kafka endpoint to the public internet, or there might be different connectivity issues. With Kafka connector, you can do that, and then you can produce EventBridge events. And then, yeah, you can use EventBridge to just route those events to different destinations. So the question came from Daniele as well. How and what type of connector should I use for my use case? And essentially, if we look at differences, first of all, with EventBridge pipes, in addition to Kafka, you can also consume events and connect other sources like SQS, DynamoDB streams, Kinesis. So there are more different ways how you can consume events. And then you can publish them not only to EventBridge directly. Sometimes, for example, if you want to get events from Kafka and invoke maybe step function state meshing, you can do that with EventBridge pipes directly, so you don't need to have like an intermediate connector here. And also, EventBridge pipes allows you to do filtering and enrichment. So if you get an event from Kafka and you want to change it and maybe enrich it or filter out, you can also do that with EventBridge pipes. While with Kafka connector, you can only consume events from Kafka topics, and you can only produce events to the EventBridge. So you can't make any changes to those events, you can't enrich them. And there was a quite interesting limitation because when you start connecting different services, you start to understand that there are different quotas and limits for those services. And for example, if you use Kafka, you can produce messages or events up to 10 megabytes. So they're quite huge. But if you use events with EventBridge pipe or EventBridge, the limit is 256 kilobytes. And the problem here was that if you use Kafka connector and it sees that the event is bigger than 256 kilobytes and it cannot publish that event to the EventBridge, it will notify you and tell that, yeah, I can't produce this event and put that event back to Kafka DLQ or somewhere. So this event won't come to EventBridge. And there's no option how you can do that. But in Daniele's case, it was the case. Sometimes they produced, because again, it was like a central event bus for all the domains. So they tend to have bigger events in these Kafka topics. And the option with EventBridge pipes allowed us to solve this problem with claim check pattern and with enrichment step. And we will tell you a little bit more details during our talk how we implemented that. So the choice was made, and for this use case, we decided to move with EventBridge pipes.
So when we decide to move with EventBridge pipe, I raise other type of questions. Now, my original architecture, some microservices were sharing internal or private event to the company bus. So this is not how a microservice should work, because if a microservice expose publicly its internal state, now you can have a random team in the company that subscribe to that event and you tightly couple it together. So if you want to change something, you will break the other team. So because of this, I also raise another type of questions. How can we decouple this? And Roman explained how to decouple it.
Yes, exactly. Another thing, we were right up until now, we were talking only how to get events from Kafka and publish them to the EventBridge. But also there was another thing we had to solve, how if we have some events originating from Daniele's domain and Daniele's services, we still need to publish them back to this central bus, because we still need to notify other customers and other domains that something has happened. So the solution we came up was that we have this Kafka on-prem running and managed by Confluent. Then we have an EventBridge pipe consuming events from these Kafka topics and publishing them to the EventBridge. And here, the interesting thing, you see that we have several EventBridges because inside Daniele teams, they also have like different responsibilities and different contexts and different teams building different parts of the application. We decided that there should be a central EventBridge which connects different bounded contexts and different subdomains inside Daniele's service. But each team inside this particular project was also responsible for a specific functionality and specific business logic, and they will have like their own internal event bus just to connect the specific things internally, not to expose and not to share unnecessary things and unnecessary events to the outside world. So the flow was like we consume events from Kafka, then we use EventBridge central hub to subscribe to the events from the Kafka for the particular services who are interested in a specific events. Then those services, they do some processing, they implement their own business logic, and at some point of time, they may also produce events back to this central hub, EventBridge hub. But now the question came up how we can publish those events back to the Kafka if we want and need to do so. And we also considered two alternatives here. The first alternative was, it's easy. We can create a Lambda function. We can have an event bus rule, invoking this Lambda function, and then in Lambda function in Java, we write Kafka producer, and we just publish those events. But our ultimate goal was to write as little code as possible, because the team didn't want to maintain, to test it, and want to have like a standard way of doing things. So we looked at alternatives, and the alternative was to produce events via API destination, because with Confluent Kafka, you can also expose a REST API endpoint, where you can just send a REST API post message, and it will just publish that message to a specific Kafka topic. And with EventBridge, you can have this API destination, which automatically do that for you. You just have a rule telling that, yeah, I want to publish that to the API destination, and then you configure the API destination just to point to this REST API endpoint, and then the events will be published. But it worked well, but as usual, with any AWS or external services, especially when you go to this serverless domain, you should be aware of different quotas and limits. And although we tested all the limits and quotas on EventBridge and API destinations, it turned out that Confluent also has its own limitations. So if you publish more than 3,000 events to Confluent REST API endpoint, your events and your messages will be throttled. And of course, there's things you should consider, and you should also think, yeah, if you don't write any code, it doesn't mean that there won't be any issues, any errors, and you still have to think how you will handle errors on the endpoints. Of course, you need to introduce some dead letter queue, so that if you don't want to lose any events or messages, then you should implement retries and dead letter policy so that you preserve all the events. But in general, this was the schema we wanted to implement, and we went into the implementation.
So after Roman explanation, this is how I work usually with Roman. With these three questions, he always gives me all these speeches. In the end, I decide the final architecture. So I have implemented the bus-to-bus architecture for all my services. Remember, as a content discovery, I own multiple services. Now I expose one bus for the entire, for all my microservices, and each microservices has its own local bus. Instead of implementing an SQS, SNS, all my microservices communicate to each other with their local bus. If a microservice A needs to communicate to the microservice B, it will pass through the local bus to the content discovery bus, and move the formation back to the other microservices. All of them do not know anything about Kafka, and all the integration is made through the team bus. This is called Event Bus Mesh. This actually allows me to fix the problem of exposing private event on the company bus. And now the microservice can actually grow in complete isolations. I can control the publishing and the subscribing of the message based on the requirement of the microservice. When we are talking about event-driven application, we need to talk about the type of the schema. So we usually have sparse event and full state. They have their own trade-off. Essentially, sparse event is the bare minimum information. This means that the subscriber need to retrieve the data for functioning and could put some load to the service that hold the data. Full state, instead, you are receiving everything. But if you want to change a property, add something, remove something, you will break the interface, and you will end up with a different type of problems. Why I'm talking about this? We mentioned before that Kafka can have a payload size much bigger than any serverless service of AWS. This means that if the payload that is coming from Kafka is way bigger than 256 kilobytes of any EventBridge, SQS, SNS, the message is lost. You have no idea why and how. So there is a solution for that, and this is called the claiming check pattern. The claiming check pattern is very simple. You are getting the original message, store it, in this case, S3, and move the S3 reference to the downstream service. So in this case, my target is EventBridge, and EventBridge will find out to the other downstream services. The advantage is now, regardless from the payload size, the system will just work. You improve the performances because you don't need to move a lot of data all around with just a reference. And I can actually fully use the target batch, in this case, 10. If you want to use, you always need to remember that one message in EventBridge is 256 kilobytes, but also 10. So if you want to use the full batch, you need to make sure that the 10 messages that you are passing to the EventBridge are a total size of 256 kilobytes. So I will show you now a service, a bookmark. It's very simple. Bookmark essentially is a user that wants to bookmark a video and watch it later on, okay? It's a video ID and a user ID. This service uses everything that we just talked about. There is a Kafka event. This Kafka event will end up inside the pipe with a enrichment pattern. We will store it in S3, move the reference to EventBridge, and we will find out. The bookmark service is interested to know when a video is marked deleted, because now need to find all the user with that video and delete it, right? This, we will use the S3 notifications with EventBridge, where we will trigger an EventBridge rule with an HTTP API destinations that will go to an API gateway as a proxy, where we will have some VTL that will delete an item in DynamoDB. DynamoDB will have a stream. The stream will go inside another pipe, and then we will have other HTTP API destination that will synchronize the deletions operation with the cache, and will send a message back to Kafka for synchronizing this operation with other teams. No? We will emit an event bookmark has been deleted. Now, from this beautiful animation, you can see actually the flow. So here, I actually leverage the serverless offering. I use their managed service, all of them. I then just put them together, and now I have an available, scalable system. All of these services, all my services are multi-region because we are present in multiple regions. And I actually wrote 2 Lambda in this case. The first one to store the message inside S3 to get the reference, and the second one in the bookmark to find all the user that bookmarked that video and store them in S3 for logging reason, where there is the event that will trigger the automations. That's it. It's very simple. It took me 2 hours, pretty much, to build this service instead to reinventing the wheel, right? So with this, we can actually move to my AWS wishes. Integrating Kafka with serverless service is not without any issues. So we saw that if the payload is bigger than SQS, SNS, EventBridge, the messages got lost. So, and EventBridge will give you, pipes will tell you bad request, but it will not tell you the payload size. You will not know why this is failing. So my first wish is an increase of payload size, ideally up to 6 megabytes, like a Lambda. So I don't need to take care to know every single quotas in the AWS ecosystem. And because the EventBridge or pipes or HTTP API destination allow you to send a message, a failed delivery to a DLQ, I would like that automatically this DLQ is actually become an S3. Because even if one of these services failed to deliver to the target, they cannot store the failed message in any DLQ. I mean, the DLQ is still 256 kilobytes. So the message disappears from your system without you knowing about, right? So this will become an issue because you can have out-of-sync data some around and you will never find out. Better metrics. Pipes just got some metrics in the last event, but HTTP API destination is still a black box. I don't know how much do I use, if they get throttled. I don't know anything about. And because we're talking about API destinations, I would like to have better quota. By default, you are getting 300 requests per second. Maximum is 3,000 requests per second. If you want to go more, you cannot do it. This is a hard quota that they cannot change. The only way to go around is to duplicate your HTTP API destinations, add the custom rules where you are setting a parameter at publishing time. So in this way, let's say a random numbers, and the EventBridge rule will listen to these numbers and route the message. This is the only way. Kafka as a target, or also S3 as a target. In this way, I will actually I will write less code. Currently, based on the service and the amount of requests, I decided to use the Kafka proxy with HTTP API destination, like in this case, or I use a Lambda. If I could target Kafka as with pipes, I will not even do this. I will just configure it, and I will have less problems. AWS will take care. S3 is because in this way I will stop to write the claiming check pattern. If I can just move straight away the payload to S3, from the S3 I can have the events to EventBridge. And from there I start. So end of the day, I don't want to write code. I have so many problems. Less I write, less responsibility I get, the better I am. Because my infrastructure is all multi-region, I would like to use the global endpoints of EventBridge. That actually is not global at all. It's a failover configuration that allows you only to replicate the messages in 2 regions. And you require to write code in a Lambda. So I would like to have it as a target as well. But last but not least, every time that a message fails to be delivered, it goes to a DLQ in case the payload is small. But you need to write custom code to redrive and to resend this message in. So I would like to have this basically automatically as all other services. If I get all of this, I will be super happy. And I will actually not write a lot of code, anything else from your side.
Yeah, thanks. And it is always valuable for us as AWS to talk to such customers who provide a lot of feedback and a lot of wishes, and we take them into account, and hopefully sometime soon we will implement them. But if we look at the summary of today's talk and what you should take out of implementing Kafka and integrating it with EventBridge pipes. So yeah, you can do that. So if you have like a Kafka as a central event bus, or you already use Kafka to publish events and messages, it doesn't prevent you from using EventBridge for certain use cases. So if you want to get most out of EventBridge and you want to have like an event router and publish those events to different destinations, you can integrate Kafka with EventBridge. And there are two options how you can do that, either by using EventBridge pipes or using open source Kafka connector. Also, if you start implementing as much as possible with serverless first mindset, and you start using different built-in functionality of those AWS serverless services, you can reduce your complexity and costs, so that you don't use unnecessary Lambda functions, you don't write unnecessary code, you don't have to maintain it. And usually you can increase your scalability and flexibility. And of course, the less code your developers are writing, so the less responsibility are on your teams, so the less you need to test and to monitor. So all of that things, if you go with a serverless first approach and using native capabilities of EventBridge, EventBridge pipes, and other AWS services, they can bring a lot of value to you. With that, thank you very much.